Today, let's talk about the enhanced for loop in Java. It's sometimes called the for each loop to distinguish it from the traditional Java for loop. The enhanced for loop provides a looping construct that allows you to iterate through an array or collection of elements without the need to use an index value. The general form of the enhanced loop is seen here, where variable is set to each element of the collection and then executes the statement. Of course, the statement could be a block of code between curly braces, so you can execute as many statements as you want in a loop. Collection must be either an array or an object of a class that implements the Java Lang iterable interface, such as ArrayList, LinkedList, or stack. Now let's take a look at some code and how we might use the enhanced for loop. We'll start by declaring an array variable called string01, which will contain an array of strings. And we'll assign it a set of initial values. We'll set it to Alpha, Bravo, and Charlie. Notice when we assign the values during initialization, the size of the array is not specified explicitly. Now let's create our enhanced for loop. The variable we use to iterate through the array will be called current and is of type string. Next is a colon, and then we'll use the name of the array, in this case string01. We'll print the value using the printf statement from Java. We can use the IntelliJ live template, SOUF, to create the printf statement for us. Our format string will be a %s and a %n to print the string we supply as well as a new line character. Then we simply add the variable current to our printf statement and print that value out. Let's run the code. When we run the code, we see that the contents of the strings array, Alpha, Bravo, and Charlie, are printed. Now let's use the for loop to print a collection. We'll declare variable strings02 to be of type strings and initialize it using the asList method of the Java utils array class. As an argument, we'll pass in the string01 array we created earlier. Let's change the for loop to refer to our string02 variable. And then we'll rerun the code. And of course, we get the same output. Let's create one last example. We'll declare a new variable, string03, which will be a list of strings, and initialize it using Java streams. The of method will return a sequential ordered stream of the values in the array. And the collect method uses the collector returned by the toList method of the collectors class as input to create the new list. The net result is that string03 is initialized with the contents of the original string01 array. Notice that all the techniques used in this code have been around since Java 8. Now let's change the for loop to refer to the string03 variable and rerun the code. And once again, we get our expected result. Now let's talk about application security. Is there anything to watch out for when it comes to using enhanced for loop? Not really. In fact, using the enhanced for loop avoids many of the common problems associated with traditional for loops in Java, as well as the while loop. Those problems include off-by-one issues, in which the management of the loop count variable incorrectly indexes the collection when it runs, infinite loops, in which the code fails to terminate properly because the condition necessary for the loop to terminate is never met. It also avoids the problem of using untrusted or unvalidated data as the loop count variable when iterating through a loop. Finally, accidental updates to the iterator count within the body of the code can be avoided as well, since the for loop neatly handles the iteration process, relieving you as the developer from that duty. In short, the enhanced for loop is a security best practice and should be used whenever possible. Thanks for watching. To get our free ebook on how to write more secure Java code, go to www.beginsecuretraining.com. When writing code, remember to always begin secure.